Welcome everybody in the lecture hall. Welcome everybody on Zoom. Welcome everybody from the future. Today we are going to finish data definition with SQL, what we started last week, and then we'll continue. This is a practical part, and then we'll continue with a theoretical part. So this is just a summary of some of the types that are available in PostgreSQL. I told you there are dialects of SQL, and it might vary between the products, but you just need to look at the documentation every time. So these are the actual types that you can use when you declare your tables with SQL. And then we saw that you can create tables using the create table instructions. You can drop tables with the drop table instruction. You can insert values in tables like this with insert into instructions. And in that case, it's a table with just one column, and we insert one value, the first one. We saw that you can also specify the name of the column here in parentheses. Here we insert another one. And we stopped here where this is where we insert plenty of values here. Here there are as many values as columns in the table, and that gives us this table right here. Now I have to say something, because we said that in the model, the column order doesn't matter, right? So normally it shouldn't matter in what order you put the columns. And here you see that the implementation, this is one implementation of the standard, actually kind of assumes an order because you're inserting the values without specifying the columns, right? So this is the real life, right? In real life, the separation might not be absolutely perfect between the physical and the logical layer. The order here would be the same one as what you put in create table, right? The order of the columns. However, you can also specify the columns, and here you're kind of more respecting the fact that there is no order in the columns. And so here you really say first name is Spock, birth date is 2230 January 6, scientist true, passport scan. That's some binary. We saw these blobs, right? So some sort of encoding of a picture, right? And something new here happens because also on this example, because I have 6 columns on my tables, but I only specified 4 of them. So what's going to happen with the other 2, middle initial and last name? Well, they are set to null, right? And I'll come back on the semantics of null, but it basically means that there is nothing in there, right? So this is what happens if you don't have any value. It's just going to be some null. So there are 2 ways to look at it with the nulls, and actually not everybody agrees, and some systems even distinguish the two. Null could be interpreted as the absence of value. So technically in the relational model, it would kind of mean a breach of relational integrity because we would have missing attributes in some of the records. This is one way of looking at it. So you kind of accept that little breach of relational integrity as long as you don't add columns. You only omit some of them in some records, right? So that's one way of looking at it. The other way of looking at it is that the domains are extended with one additional value that is null. So for example, if you have the integers, it's actually the integers union null, right? And then you still have relational integrity. You just accept that null is also by default in all of the domains, right? So these are the 2 ways to look at it, either the absence of value or a special value. Now, how do you interpret this? It might be that it's not known, right? It exists, but you don't have it, so you just leave it absent in the table, and maybe you'll add it later. Maybe it's not applicable. In that case, actually, that's the case because Spock doesn't have any last name or middle name, right? Or it could be that it's a secret, right? You don't have the rights to actually view that, and so you don't get the value, right? But basically, that exists. So in all of the SQL database management systems, you have this special value or this absence of value semantics of null. For whom is that clear? All right, okay. Now, how do we disallow nulls, right? We might not want to allow null in a column. And in fact, that's possible. All you need to do is specify it in your create table statement. So if I add this not null after my first name varchar 30, which is a string, then it's not going to be allowed, right? And if you try to insert something omitting that value, it's not going to work, right? You're going to get an error. and it's going to tell you it has to be not null. It has to be an actual string. Okay, so you can just add this here. Again, here it's in uppercase because most people use uppercase for SQL keywords. I don't think it would complain if you put it in lowercase or even any combination of upper or lower, right? But somehow everybody does it, so it's a good thing to take the habit of also using uppercase for this, not null. And if you want, you can still add null without the not, then it's allowed, but actually you don't need to do it because that's the default anyway. If you don't say anything, then it's considered to allow the nulls, right? So that's it. You can have null or not null. And it's a good idea to try to be restrictive rather than too permissive, because you don't want to have any trouble later, right? So you might want to require some of the fields and not accept them to be null. But again, be careful because you can always have exceptions that can come later, right? But you can still change the schema and then allow them. All right. Next, you can update tuples, right? We inserted tuples, now we can update tuples. So how do I change some values in there? Well, there is an update statement, and I can just say update persons, that's the name of the table, sets the last name to Picard, where last name equals Crusher. So it's going to find the records where the last name is Crusher right here, and it's going to change it to Picard, right? I'll come back to this where statement in the next few weeks, because actually this is called also a selection, right? But so there is actually something more to it. But here I'm just showing it in the context of updating records, right? So you just have some criterion to pick the record that you want. We'll see that it's called a selection, and then you can change it. All right, and then you can delete. So you can delete, for example, all the records. The first name of which is Spock, and then that's it. It only has 2 rows left. All right, so far so good? Everybody's following? Okay. Now let's get to the default values. Default values are if you don't want to specify all the values when you insert them, but you're also not happy with nulls, because nulls is what's going to happen if you don't put all the values. But if you're not happy with having nulls, you can specify a default value, right? There is a question. That's a good question. Maybe we can research it. In that case, it's assuming you can make assumptions, right? And we'll see later in database design theory what it means. It can be that you have the knowledge that the first name value is unique. Obviously, that's not the case because there can be several first names. That is just an example. And then you know it's only going to be one. Now, if it's several of them, some systems allow saying, you know, it might be several of them, but just change one. I don't know if PostgreSQL does that. So maybe you can actually look during the lecture if you find in the documentation. Some systems support that, especially the NoSQL systems. So we'll research if PostgreSQL lets you do that, right? Note that if it would, that might be a bit random, right? You don't have a guarantee on which one that would be because that's set semantics, right? So we'll get back to that and see what our findings are. Okay. All right, so now I'm saying if I don't specify any middle initial or last name, then I want my middle initial to be N and my last name to be none, right? These are strings, right? Very important. None is not a special value. It's really the string N-O-N-E, right? So now if I try again to insert the values just like before, now you notice something happened here. It didn't put nulls. It actually puts the N in here and the none in here just because we defined them in here, right? Default N and none. So this is what happens with default values. And the default value, so the default value, if you don't specify any, is null, right? So that's why the first time it was adding nulls. Okay, so far so good? Okay. Now we know how to create tables, how to drop tables, how to insert values, how to update values, how to delete values. Let's look at modifying the schema of a table after we have created it and populated with values. So the first that comes with a warning, that's not the sort of things you want to do every day, right? First, because if you have 1 million or 1 billion entries in your tables, that might take a while to actually do this. And also because you might break things, right? You might have some programs in Java or C++ or Python that access the database and assume some schemas. And so you have to be very careful, right? In fact, that sort of things, when a company does that, typically comes with the hiring of strategic consultants from one of these big companies that spends months planning the migration to the new schema and so on. So just to say, be careful with that. It's possible, but it's not something that should be done too lightly. So modify a table. So the first thing you can do is add a column, right? You want to add a new column. So we say alter table, hello world table. I have it right there. And I add column flag. That is a Boolean. And that's my new table, right? So of course, if I do that, null is allowed. So it's probably going to put nulls everywhere if there's already values in there. So it's going to extend add one more attributes to every record and set it to null, right? And of course, you can also specify other things in there, like, for example, not null default true. So that's going to put a true in all of the records, right? Now, if you try to do that saying it's not null and you don't specify a default value that is not null, then this is where you might be in trouble, right? So you have to think about what you're doing, right? So if you're adding it and you don't have any value yet, you have to tell PostgreSQL what to put in there by default on all the records. So here is going to be null, added to every record, and he's going to be true, added to every record. And then, of course, you can modify the records with set, as we saw before. Okay, so now we add another one, flag2, that is not null default true. So flag will be null everywhere, and flag2 will be true everywhere when you do this. Okay, now you can rename columns. So if you have, for example, name and flag, and you say alter table, hello world table, rename column flag to F, this is what you get, right? You change the name of the column, right? So again, be careful, it might break a few things if there are other people who were depending on the name of the column. You can also drop columns. So drop column F, just get rid of it. That's going to remove a lot of values from every record. It's going to remove the value. Here also a pinch of salt. It's the same. I will come back to these constraints, but basically, just in the same way that you have constraints about null, not null, you might have other constraints that we just haven't seen yet on the table. And it might be that if you drop the columns, then suddenly these constraints are no longer fulfilled, right? So you have to also be careful about these things, right? But here I assume there's no constraint that prevents us from doing this. And I can also rename the table itself, right? Hello world table, I rename it to table, and that's it. Okay. Okay. All right. Now I'm moving on to the consistency constraints. So now you know how to create tables, drop tables, modify tables, add values, modify values, and delete values, right? So we've already covered all of that. Now, what about the constraints that you can add to your tables? So a constraint is basically some additional thing that the values in the tables must fulfill, in addition to the constraints about the names of the columns, of the attributes in every record. So that's the relational integrity, in addition to the domain integrity that forces you to have the same type or null in every column. And in addition to the first normal form atomic integrity that asks that the domains are all atomic, we can add more of them, not just these three, but more. And I'm going to cover these three, plus probably the foreign keys as well, which could be considered a consistency constraint as well. So this actually we already saw, right? That's the not null. We can add some coded, self-coded in the sense that you write them down, so customized checks, and unique. All right, so non-null we already covered. That just prevents the value from being null. By default, it's allowed, but if you want to forbid it, then just make it not allowed, right? It can be a good thing also to explicitly put null if you want to really clarify in your schema that nulls are allowed, right? But it has it makes no difference in practice. All right, so in the name column, the null on the left would not be allowed. I put a cross in there because that's forbidden. So it would not even let you do this. But the null on the right under student would be allowed because here you're not specifying not null in the schema, so it's allowed. Okay, so this is how it works. And to be clear, PostgreSQL will not let you create a table like that. It will throw an error and it will not even do it. Okay. Now the second one is check. So I can add it either to a single attribute like here. So here I say the name cannot be Spock, right? It's just an example. And then if you try to actually put it in there, it's going to throw an error. You can add checks on multiple columns. It's a bit similar, but instead of putting it right after the name, you would put it as a new row below students. You would create a third row called check, and then you can use any attributes you want, right? So this is also possible for check constraints that use multiple columns. For example, you want to say that this attribute must not be equal to that attribute, or this attribute must be equal to that other attribute. Then you just do it on a separate line rather than just after an attribute. Okay. And then comes unique. Unique says it's not possible to have multiple times the same value in these columns. So if you have name that must be unique and you have twice the same name like here, this is going to be an error. It will not let you. AHV, so the social security number in Switzerland, if you say it must be unique, then that's the same. It's going to throw an error if you have several times the same one. But here you can see it's 3 different numbers. They're all made up. It ends in 3, 4, and 5. So you can see they are different. So this is fine, right? So unique will prevent you from populating the table in such a way that you would have several times the same value in the same column, right? For name and also for AHV. It is also possible to have unique over multiple columns, right? So it means that you must have unique values, but as a compound value over multiple columns. For example, you could have AB and then AC and then DC, and that would be okay because it's overall that it must be unique, right? Even though it's not unique in a single column. So if you want to say unique on 2 columns, then don't put it in after the attribute. It's just an extra line at the end again that enforces that. Last year there was a question at that point. I don't see any question now. So the question that was asked last year is, what about nulls? And there is one on Zoom. Let's first do the Zoom one, and then I'll answer last year's question.
So the question is, can we directly define that combination of 2 rows not be unique?
2 rows or 2 columns?
2 rows. Can we directly define that the combination of 2 rows?
Yeah. Can we ask back if you really meant 2 columns instead of 2 rows? Yeah, okay. So yes, indeed, that's what I mean. I think if I correctly remember that the way you do this is to add a unique, but as a 4th line in there. And then you say unique parentheses name AHV. That would mean that it's jointly unique, right? I don't think I have an example here, but I think that you can really do it either on a single attribute or on multiple attributes, right? Did that answer your question? Yeah? All right. It would just be on a separate line. Okay, and now last year's question, what about nulls? What if we have a column that must be unique, but it doesn't say that nulls are forbidden? Well, technically, this is where it's a bit blurry and not really defined in the standard, and so every implementation is going to do what it wants, but technically you can have control. So I think by default, what happens, if you make a column unique, then if it's not null, it has to be unique, but you might have multiple nulls, and that's fine. So if you have 4 rows where it's null, it's not going to throw an error for a unique column, right? In other words, it means that 2 nulls are not going to compare as equal, right? So that's what it does by default. But if you don't like that, and if you also want to forbid multiple nulls, so treat them like any other values, you can do that. And I think it's just done by adding after unique some sort of, I think the keywords, the magic words are null not unique or something like this. Null not unique or null unique. I don't have it in mind. But basically, you can control whether or not this unique would also apply to null values, or if it would not apply to null values and you would allow multiple null values, right? Okay. Good. So now we have covered check, units, unique, and not null. Let's move on to something else, primary keys. Then we'll cover foreign keys. So what is a primary key? Well, the intuition of this is, for example, here with some table of people in Switzerland that have social security numbers. Then you kind of want to say that the social security number uniquely identifies a person. In other words, if I give you the AFA number, you know what record this is. If I tell you 1, 2, 4 at the end, it's going to be the second record, Kurt Gödel, right? This is called the primary key, and we'll go more in details about the formalism of that in a few weeks in the database design theory lecture. But I'll still tell you how to declare that in PostgreSQL, right? So a primary key uniquely identifies the rows. It cannot be null, right? That's not okay. It has to be to exist. But now you're going to tell me we already know how to do that because we have unique and we have not null, right? So why don't I just put unique not null and that does the trick, right? Does exactly what I want. So this is true. However, it is desirable to be explicit about the fact that it's a primary key. Why? Because we will want it to be referenceable from somewhere else, right? So it's not just about unique not null, it's also the fact that you can use this social security number as a reference to the records from somewhere else, right? That's the idea. So then you say primary key, but again, it's equivalent in terms of constraints to unique not null, but it's also making it referenceable, okay? You can also, by the way, what I'm showing here is exactly the same for unique and check. If you want to put unique and check on a separate row, this is exactly how it looks like. It's the same syntax for primary key, check, unique, right? So here I can also say primary key AHFAO, but I can also put several primary keys like that. The same applies for unique and check. You can also do it in this way. So primary key first last would be that first and last together are the primary key, right? And again, just like unique, since we have multiple columns, you might have several times the same first name. You might have several times the same last name. You just want them together to uniquely identify a tuple. Now, this is unrealistic. We all know that in real life, there are people with the same first and last name, right? It's just for the example right here. All right, now we have a primary key of first and last together that uniquely identify the records. Okay, so now coming back to what I was saying here, we want to reference it. So let's do it. Let's reference them. So in order to reference them, this is how it works. I might have this table of persons on the right here that are all identified with the social security number, the AHFAO. So it means that here, this is a primary key right here that uniquely identifies a record. And I might have here my tax office database, right? I don't know, I'm a tax office employee and I just look at the tax reports and I see maybe for multiple years, right? So I might have several times the same social security number. But what I want is that every tax return has some social security number that links it to the person that filed that tax return. So I might have here also the address, the city, whether they paid their taxes, and so on, right? And here, this would be the tax returns. So you see that this here is called a foreign key. It's referencing another table right there. And we'll see that we can join them. It's one of the things we'll cover in the next course. We can actually put the table together and link these records. So this is called the foreign key. What that tells you is that that tax return here in Austria was filed by, drum roll, 124, Kurt Gödel. That's how it works. Yes?
It's not like a table in a table.
The mindset is correct. So you were saying, because it wasn't in the microphone, you were saying, is it not like a table in a table? Yes. You are very close in terms of mindsets. You could technically alternatively model that by nesting the table in the other one. However, we will see that this will be part of the database design theory lecture in a few weeks. So I'm basically telling this ahead of time. The idea is that if you ever have a table in a table, what you should be doing is disentangle the two into two separate tables and link them with a foreign key and primary key. So technically, what you see here on the screen would be the sort of things that you get after fixing a table in a table, right? Now you no longer have a table in a table, you have two separate tables, all of the cells are atomic, but it might be that you got that because you previously had a table in a table and fixed it, right? Does it make sense? Okay, and I'll come back to it because again, we will cover all of that in the database design theory week with the first normal form, the second normal form, and so on and so on, right? So I'll give you plenty of examples of how we take databases that were wrongly designed and how we fix them. For example, for a table in a table by splitting it into two different tables, right? We have another question right there. Maybe with the microphone, it's a good idea so we don't have to repeat. So first there, and then I'll come to you as well. Oh, thank you. Go ahead.
If we define two primary keys, but in separate lines for a same table, we'll also apply the rule for the couple. So the uniqueness rule will be applied only for the couple of them, even if it's not the same line.
So I think there are two questions in yours. The first aspect is, I think I might have it on a slide. So that's the first, that might be what you mean. It's okay to have several times the same foreign key. That's totally fine. It just means that we have two tax returns by the same person, right? But what you might have been asking, because you also asked about a combination of columns, right? So I think I have an example. So of course, I'll come to this. But basically, you can do these sort of things by saying that you have a primary key made of multiple values here, the first and last name. And then you would have a foreign key that is also made of two columns, right? So it's the first plus the last one that collectively reference the person. But then again, it's totally fine to have multiple foreign keys with the same values, right? It's totally fine to do that. Did it address your question, or was there something else?
Yeah, it's not about foreign key. It's just about a basic.
The primary key.
Yeah, a basic primary key. Imagine that, for first and last. Imagine if instead of doing that, we do primary key first, and then in another line, primary key last.
Ah, I see what you mean. You cannot do this. There can be exactly one primary key.
Oh, all right.
So you wouldn't be able to declare it several times. Instead, what you would need to do is declare the other as unique, not null, right? But it would not have the status of a primary key. All right? And we'll cover this also in the database design theory lecture. We'll see that there can be several candidate keys that could potentially be a primary key, but you always have to make up your mind and pick one. That is the primary key. All right?
Yep.
All right, let's go to you now. If we can maybe throw the microphone, let me try to catch it. Oh, there you go.
Thank you. I wanted to ask if there is such a thing as like just a key, and if there's a difference between a key and a primary key.
Key can be very general. Do you want to answer or contribute?
No. Also, there's a concept of foreign key too.
That is true, yes. So you can have foreign keys and primary keys. And in fact, the word key is even more general than that because you can find the concept of key in a lot of places. One of the examples, if it confuses you, then forget that I said it. But in big data for engineers, for example, we see that the records can be stored as JSON, and then we would also call the attributes keys, right? Oh. If it confuses you, then forget what I just said. But the word key is basically very, very generic. Whenever you have a structure that's called a map, then technically what's on the left is called a key. So what then is mapped to somewhere. Okay, so a primary key is a specific kind of key, a foreign key another one, and a JSON key is yet another one. Okay,
thank you.
Welcome. All right, any other questions? All right, let me continue then. So, but these are very good questions. So, the way I encode a foreign key in PostgreSQL, because this is what I want to show you, is with references. So I add references to my row, and I say what table I'm referencing, persons, and what column in that table I'm referencing, AHFR. But the cool thing is that if it's the primary key that you're referencing, then you don't need to specify a half-hour. You just specify the table, and it's automatically going to assume that it's the primary key of the table. Now, of course, it has to be exactly, that's the case where the primary key is just one column, right? Okay. But in general, just so you know, it would totally be fine to have a foreign key that references a column that's not a primary key. It would also work, right? It's at your own risk if you do this. But if you do, it still must be unique, right? But not necessarily a primary key. All right. And if you don't specify, as I said, it means the primary key of persons that you know how to declare. It's by adding this primary key in the schema. And now that also is part of the question you asked earlier. There can only be one primary key. That's the reason, because if you have these references, there has to be one so that it's not ambiguous which one you mean. Okay, and duplicate references here on the foreign key side are totally fine. Okay, now compound keys are also fine. You just do it as a separate line. Whenever you compound columns, be it with check, with unique, with primary key, it's always a separate line. So now we say foreign key first last, references persons first last. And again, if first last is already declared as the primary key in persons, then you don't need to specify it, right? Another thing is that in a foreign key, it's totally fine to have nulls, right? It's just you have a tax return, you don't know who filed it, right? Of course, that's the problem of the tax office, but you technically allow that, right? It might be that you don't link it to any person, right? But if you do want to forbid that, you know how to do it. You just add a not null, and that's it, right? We have a question there. Let's.
Just confused. What's the difference again between foreign and primary?
Foreign and primary? Yeah. So the idea is that a primary key, if you look at the table persons over there, that's a way to identify a person. So the social security number could be the primary key that identifies a person. If you have a table of cities in Switzerland or of Gemeinde, then what you would do is use the zip code, right? The Postleitzahl that would identically, that would unambiguously identify a Gemeinde in Switzerland. So that's a primary key. A foreign key, that's in order to reference a primary key. So it's whenever you want to link a record to a person or to a city, you just use the reference. So in the tax office, in the example of the tax office, you will have all of the tax returns, but you must link them to a person, right? You must say for every tax return, you might have 3 tax returns that you filed in the previous years, and you want to say for each one of the 3, this is you. The way you do that is you put the social security number in the tax return table, maybe 3 times, and then you know that it's technically linked to the person table. So it's a reference, right? So the primary key is to identify a person. It's in the table of the persons, a column that identifies it uniquely. The foreign key is in any other table, maybe in 10 other tables. Whenever you need to identify a person, just put the social security number, and it's kind of a proxy for the person that you mean, right? Okay, there is another question there. No, it won't. So the question is whether if you say, you meant by comment this one, right? The references, whether if you write that, it automatically declares it as a primary key. No, it will not. You really have to also declare it as a primary key in another table explicitly. Okay. All right, any other questions on Zoom? Everything clear? All right. And so you can play with it, of course, because it's PostgreSQL, right? So you can create your tables in the Jupyter notebook, and you can play with these things. All right. Now I'm going to explain a potential problem with foreign keys, and that also might help you even more understand the difference between foreign key and primary key. Because what happens if I have these persons here and I delete one from the database? But what happens if it was referenced from other places? Then I have broken links, right? It's like when you put some link to a URL to a web page somewhere and you remove the web page and then the link is broken, right? It's exactly the same thing here. So what if I have these persons and I have these references here, I have the reference to the person I'm deleting, what do we do? And the answer is, you decide. You can tell PostgreSQL what you prefer. The first one is on delete cascade. It means if I delete a person, I'm going to automatically delete everything that references it. So all the other records that references that reference that person, they also go away. It cascades basically. So you will not only remove that record, you might remove 10 other records in other tables because they had a foreign key pointing to it. That's the first choice. Maybe you don't like this. Maybe instead you want to forbid it. Maybe you want to say if you delete a person that is being referenced by other tables, maybe you just want to throw an error message, maybe a fancy one like this, and then say, no, that's not okay. And it will not even let you delete the record that had the primary key that was referenced. Maybe you want to set, that's yet another thing you can do. Maybe you want to replace the foreign key with nulls. So in that case, where the foreign key was, you just remove it, but you don't delete the record, you just put nulls in there. And you remember it's fine to have nulls in a foreign key. So now it's just that this course, completeness, is no longer bound to Kurt Gödel, right? So that's what happened, and then you can bind it again later, all right? And the alternative is to set to the default. So it might be that here you have a default that is Albert Einstein for first and last name. So then it will automatically reallocate and relink it to the default person, which is Albert Einstein. And this is assuming that in the courses table, you did declare that the default of first is Albert and the default of last is Einstein, right? So you have the choice. You can either cascade, you can throw an error, you can set to null, or you can set to the default values. You decide. All of that is declared in the table that has the foreign key, right? That was the last slide. And you survived this. Yes, there is a question?
So we're deleting from the forces table, and then it cascades onto the persons table? Or?
It's the opposite. So you basically, it's when you delete the table that has the primary key, and it cascades all the way to where you have the references, right? It's really because the person is the one that is being referenced, and if you delete a person, then all the places where that person is referenced, they have to be updated in some way. Because imagine that we don't. Imagine that we delete a person, like here, we delete a person, but we leave the foreign key. Then we have a breach of constraint because we have this constraint that the reference here must be pointing to a person. That would be broken. So this is why we have to decide to cascade, to forbid, and so on, right?
How does SQL know that this courses table is referencing then persons?
Because we see it right here that there's Kurt Gödel here, which is declared as a foreign key, and there's also Kurt Gödel there. This is how it knows.
But
of course,
we need to write some code to do that one.
PostgreSQL does it for you. But yes, the engineers that wrote PostgreSQL, they wrote some code to do this. Right? That's the benefit of SQL, is that because you have the SQL language, behind SQL, there are probably tens of thousands or even hundreds of thousands of lines of codes, probably in C++, that take care of all these things. You don't have to worry about that. Basically, you are using this language, this high-level language, SQL, to deal with tables, and everything is just automagical. Right? Awesome. Yes?
I'm not sure I understand correct, but so if we delete something from the the foreign key table, it doesn't do anything to the primary key table?
Exactly, yes.
Okay.
Because imagine that you have, I don't know, let's take the tax returns. That might be the easiest. Imagine you have all these tax returns, and you have 10 tax returns that were filed by you, for example. So you're in the persons table. There are these 10 tax returns. And maybe the tax office says, okay, now it's 10 years old, so I'm going to remove it. That's fine, right? It doesn't mean that as a person, you should no longer be in the persons table, right? So the tax return, they can really be deleted at will, and it has absolutely no impact on you, right? And the idea is just they were 10 years old, you remove them, but you still have these other tax returns that you filed. And even if they deleted all of your tax returns and you're still in the persons table, that's totally fine too. It might be that as a person, you can be referenced from other places, right? So there is not even an obligation that every person is referenced somewhere. It's totally fine if there is absolutely no reference for some person, right? So this is some of the differences between foreign key and primary key, right?
Just making sure I'm getting this.
Mm-hmm.
The last slide, creating the foreign key reference of the last and first name to the person's table.
Yep.
Then we delete something from the person's table.
Yep.
And automatically cascades.
If you say cascade, if you say on delete cascade. Yeah. Yeah, that's exactly it, right? It's if you delete in the person's table, the one that has the primary key, if you delete there, then all of the places that there was a reference to them, which has to be a foreign key, then it cascades or constrains or sets to null or sets to the default, right? But when I explain this, it's really what you delete, that's always where the primary key is. And where you cascade or constrain or set null or set default, that's always where the foreign key is. It's always in that direction. Right?
Can you execute some other code other than delete?
I could imagine, I didn't really cover that, but I could imagine that you might want to replace some value and something. So if you, I don't know if it will allow you to, but technically, yes, you could modify a primary key. Then I don't know what would happen if you modify, like imagine you update a social security number of a person. Maybe imagine the upgrade from the old social security numbers with 11 digits to the ones with 13, which was a few years ago. And you update that. Then I see two possible behaviors. Either you consider, okay, it's just as if you deleted and added it back. So you use this, but I could also imagine some automatic updates. It means that if you change the social security number from 11 to 13 digits and you update it for one person, I would assume that PostgreSQL might be smart enough to update the foreign keys everywhere else to the new primary key. It might be, I'm not 100% sure, but I would imagine that that's the sort of thing that a relational database management system would do for you, right? Yes? The primary key cannot have duplicates because it identifies a person, must be unambiguous, but the foreign key can come in duplicates. The reason is simply that you can have 10 tax returns, right? And that's why you could have 10 tax returns that all reference the same person. But there's only one you in the person's table, right? Okay, all right. So it's a bit tricky, but I hope that that it makes sense. We have maybe one more question before the break from Zoom. Oh, so it might be that you would manage to do that, but you should really try to always reference a primary key, right? The regular use of a foreign key is that you should point to a primary key. So if you have a table, a third table, that you write references, courses first, last, it might be you're able because it doesn't enforce the primary key, but you might start observing weird behavior, right? So it's not recommended to do that. It should really, what you put in the references should really be a primary key. Now, to try to answer your question, I would imagine that then it would cascade. That would be my guess. It would first cascade from persons to courses, and then it would cascade for courses to the third table, because the third table would have this on-delete cascade. But again, and this is also to not confuse you, try to stick to always using primary keys. When you say reference this person, put primary key in there, just to keep your sanity, right? It's probable you would be able to put something that's not a primary key, but really, especially for the sake of learning, put a primary key in references. That makes it crystal clear. Okay? Did I answer your question too? Awesome. I think you've deserved a break, and that's good because this lecture is actually over. So this part, we'll do the relational algebra in the second hour. So take a good break, relax, go get some coffee or orange juice or whatever. And I'll see you at 15 past 11, quarter past 11. Thank you.